Hi, good afternoon all. I welcome you all to the third edition of Tool Talk. Myself, Nishant Kashyap. I am editor of TAGMA Times. It's a monthly newsletter of TAGMA India. Thank you all for joining this session. Today we will discuss possibilities of Industry 4.0 and how it would shape the future of manufacturing. For that, we have Dr. Asim Tewari, Chair Professor and Chair Profession of Mechanical Engineering, Indian Institute of Bombay. Welcome, Professor Tewari. Hello. Yeah. Now I would like to request Mr. Shanmuga Sundaram, Vice President of TAGMA India, to say a few words about Professor Tewari. Over to you, Mr. Shan.
Yeah. Good evening to one and all. On behalf of TAGMA Executive Council and TAGMA members, I welcome Dr. Asim Tewari for this Tool Talk event. I would like to give a small intro to all the listeners about the doctor. Dr. Asim Tewari is a professor in the Department of Mechanical Engineering and a faculty member of the Center for Machine Intelligence and Data Science at the Institute of Technology, Bombay. Prior to this, he was a staff researcher at General Motors Global R&D Center in Bangalore. He graduated with a BTech degree from IIT Kanpur, following by an MS and PhD from Georgia Institute of Technology, Atlanta, USA. After his doctorate, he was briefly with the National Aerospace Laboratories, Bangalore. Subsequently, he joined IIT Kanpur, where he served as an assistant professor before joining General Motors Global R&D Center in Bangalore. At IIT Bombay, he has been instrumental in setting up the National Center for Aerospace Innovation and Research Center for Technical Textiles. His personal area of research is in mathematical models for microstructural mechanics. He has over 100 international journal and conference publications and 10 international and 4 Indian patents. Now, today, Nishant will interview Asim Tewari. I once again welcome Asim Tewari, Doctor.
Thank you.
Thank you, Mr. Shanmuga Sundaram. It was nice to know more about Professor Tewari. And Professor Tewari, you may not be aware of this, but I worked in this NCIIR project 10 years back when it had just started. It was my privilege, and now glad to see it has grown to a certain level. Now, let's begin today's session with our esteemed guest. As we all know, today's session is all about IoT and smart manufacturing. And we have been hearing smart manufacturing is coming for years. Further buzzwords like, industrial Internet of Things and digital twins have been posed around as a next new thing for some time now. We have also been told the Industry 4.0 is influencing sectors like manufacturing, supply chain management, construction, shipping, and shall impact all our aspects of our day-to-day activities as well. It is considered to be disruptive technology. However, there are several misconceptions about it, leading to the slow adoption in India. In the next 45 minutes, we will discuss about Industry 4.0, the misconception, how the factory of the future will look like, how the Indian SMEs can adopt to India Industry 4.0 and its benefits. All that and more we'll know in this session. If you have any question, you can post that in the chat box below. Mr. Tewari will address after our conversation. Also, I would request everyone to keep yourself in a mute mode so that we all can enjoy a interruption-free, conversation. So my first question to you, Mr. Tewari, is if you can just start with the concept of IoT and smart manufacturing. What is it according to you?
So see, smart manufacturing is a very comprehensive word. It's actually not one technology. And for instance, what we call as Industry 4.0 in Germany and Europe, and smart manufacturing in United States and India and many other places. It's not actually one thing that you call this is a smart manufacturing or this is Industry 4.0. It's essentially a collection of many different technologies, which in an entire offering is what we can call as smart manufacturing. But in a nutshell, there have been possible definitions. People have tried to define smart manufacturing. There is one very popular definition which talks about the 9 pillars of smart manufacturing, which includes autonomous robotics, simulation, which is a virtual model essentially, then vertical and horizontal integration, looking at industrial Internet of Things, which is one integral part of this, then cyber security, cloud, additive manufacturing, augmented reality, and big data. And that's one view of how you may want to define smart manufacturing. But that's not something which is agreed upon by the global experts. And the definition varies from groups to groups and from sectors to sectors in that sense.
Okay. Okay. So thanks for this definition, and we understand that it varies country to country and group to group. So what are the various components of smart manufacturing, and how tooling suppliers can benefit from IoT or the smart manufacturing, as we say?
So let me go and take one step back actually. So if you look at the word smart manufacturing, and we will try and avoid the term industry 4.0 because that has a very specific context from the day it was coined in Germany. So if we talk of the bigger, I would say area of smart manufacturing and take a step backwards and just look at the word smart. So essentially the word smart wants you to understand that it is not the traditional way of doing things, but it's a smart way of doing things. So in a minimum definition and a minimalistic definition of a smart manufacturing, our view, and this is a very large set of people, but I belong to that group which feel this view. So from our minimalistic definition of smart manufacturing is something which is smart. And thus it requires you to have some network linked intelligent system capability in manufacturing. Now that essentially removes the entire aspect of robotics out of the smart manufacturing, which essentially is a very clear distinction, because what we are trying to suggest, and many of us have this belief, that smart manufacturing does not mean automation. Automation and smart manufacturing are two very different aspects. So you could have smart manufacturing without automation, and you could have a smart manufacturing with automation. So the key ingredients for a smart manufacturing would be essentially a network linked intelligent system application in manufacturing. Now coming to specific aspects of what really can it do for the tooling industry. So before that, let me just see what could it do for instance, for manufacturing at large. So there is a very, very common term which is known as cyber physical systems. And this is basically where you have lots of connected virtual entities. And the smallest entity of a cyber physical system is a digital twin. So essentially, digital twin could be considered as the smallest entity of a smart manufacturing system. And that is something which can work for every manufacturing scenario, including aspects of the tooling industry. Now, at the end of the day, you already are making tooling, you are already producing tools, you are already in business. So what else can smart manufacturing actually do? So the basic idea is as to what can actually smart manufacturing do differently than what you're already doing, and how to monetize it. So that's the bottom line, that can it affect your bottom line, and can it actually lead to higher productivity and aspects associated with your bottom and top line. And that is where it is no different from any other manufacturing industry. Tooling industry is no different from any other manufacturing industry, and it can benefit. Now, if you go back and look at what really are the basic drivers of cost. So in any production facility, you essentially have a very simple mantra. You want faster, better, and cheaper. So that's the basic things. Faster means you want to produce more. Better means you want to have a better quality. You don't want to let your quality slip. Actually, you want to have your quality keep going up, and you want it all cheaper. And these are the basic three aspects. You can, of course, define better, faster, and cheaper in many different ways. And you can bring in environmental factors, carbon footprint, energy consumption and all those aspects. But basically, these are the three basic drivers which drive any manufacturing facility, and so does it drive the tool making industry. Now, the aspect is that what are all these three being affected by in smart manufacturing? And that is a much bigger question. But essentially, in a nutshell, smart manufacturing will help you achieve all these three. It will achieve you produce better, faster, and cheaper. And one has to really look into their specific businesses and see how it will help. So just to give you an example of the tooling industry. So for instance, if you look at what really are your major cost drivers, apart from the raw material, the resources, human resources, power, your other major cost drivers are disruptions. You could have a failure of your equipment, a downtime of your equipment. You could have aspects of your human resource not available when you need production, and human resource being available but you have no production. So there are mismatches in management of human resources. So these are the main cost drivers. Other cost drivers are pretty much fixed. Your raw material, your other aspects of consumption of power are pretty much fixed. And these can be optimized using smart manufacturing. So this is in a nutshell what I would say is the benefit which tooling industry could have.
Okay, that's great. That's insightful. So if you have to divide it in what are the various or key components of industrial Internet of Things, like predictive,
So,
preventive, and then how to go about it, like.
exactly. So industrial Internet of Things is essentially like the senses of a human being. So if you look at smart manufacturing, a very key ingredient of smart manufacturing is industrial IoT. And the industrial IoT are the eyes and ears of your intelligent system, which is the smart manufacturing system. So now we are having phenomenal growth in IoT devices. There are billions of IoT devices currently available, and they are growing extremely fast. And what are these devices? These devices are essentially sensors with a basic capability of doing some kind of onboard processing and a capability to transmit that data. So these IoT devices are all over the sector, not just in manufacturing. They are there in health sector, agriculture, military, smart cities, automation, home automation, you name it. Almost every area has these IoT devices which are available. Depending upon the level of criticality of the data which you're getting from those IoT devices, the pricing of those IoT devices can change. So essentially, the basic ingredients of an IoT device are the sensing capability, a capability to do some processing, and a capability to transmit that data. So that becomes the basic ingredient for an IoT device. Once you integrate that IoT device with an asset, let's say an equipment, that's when you can actually create a digital twin of it. And to basically answer your question more precisely, a digital twin could be looked at as an entity which has some basic minimum requirements. So an IoT device is an essential requirement for a digital twin. But what else does a digital twin or a cyber twin has? If you look at a cyber twin, the definition, the way it has evolved over the years, there is no real consensus, but a generic definition which has come out, which now pretty much everyone accepts, is that a cyber twin is a virtual incarnation of a real physical asset. So you essentially have 6 basic ingredients in a cyber twin: a physical asset, a virtual CAD model of the asset, the IoT devices, which essentially are the sensories organs of that device, which connects the physical device to the virtual device. Then you have analytical simulative capability of that device. Then you have a intelligent capability of the device. And finally, you have a communicational capability of that device. So if these things become, then you get a digital twin.
Yeah. Okay. So thanks for the whole definition about the smart manufacturing and industrial IoT. So if you have to talk about the challenges, what are those various challenges in implementing IoT in existing systems?
So one can divide the challenges in many different ways. So there are some technological challenges. Probably the biggest technological challenge is the internet itself. So IPv4 has a limitation of how many unique addresses you could have. So world has seen IPv6, but still most of our devices are still working on IPv4. So that's one of the technological challenges for which we already have the solution. But we have to really move out of the V4 to V6. That's when we'll be able to have many more devices possible. Right now, the limitation is about 4 to 5 billion devices, 4.5 billion devices. but that's a very small number. We cannot have just 4.5 billion different addresses. So that's one technological challenge. Another very big technological challenge, which is more man-made than anything else, is the fact that we have all different standards. There is no standard way of communication. This is a unique problem, what we call as, basket of remote problem. You have 10 different devices, all by different manufacturers, all having different protocols, interacting with 10 different applications and dashboards. All of them are talking different languages. In the near term, it can be addressed by having standards. And there is a lot of progress which is happening in this standards. There are big companies around the world who are able to actually streamline, because everyone wants to have their own standard. So you need some really big players to come on board together and set up a standard. So that's a very big challenge of the not communicating devices. All devices have their own standards or unique proprietary standards. The third biggest challenge, I would say, is the cost, which is a non-technological challenge, which is the initial investment. And now this is one area which has really changed in the last maybe 5 to 10 years. The cost of these IoT devices have become extremely cheap. And depending upon the level of authenticity or level of data criticality you need, if you don't need a lot of critical data and you're not depending on it for making some very critical decisions, then IoT devices could be extremely cheap. So a slightly less reliable, highly cheap IoT devices are available today. Of course, the very high reliable devices are still very expensive. So for instance, if you would like to have a pacemaker inside your body and you want it to communicate, you want it to be highly reliable, and that will be expensive. So these are the three biggest challenges. And the last challenge which we, for instance, in India may face is the human resource challenge. And this is something which we are seeing every single day, that we do not have enough trained manpower in this area in India, which is not the case, by the way, in Europe and in US, where there has been a constant effort to create a large human resource which is capable of doing this. But this may become the biggest challenge for us in India.
So right. So you have highlighted the challenges overall the industry are facing. However, if we talk specifically about the tooling industry, where we see not everyone is even come to an automated level. Of course, you said that automation in Industry 4.0 or the smart is very different from each other. But there are many companies who are still operating in a very conventional manner. So how feasible it is for them to go for such a high-end technologies and automate, make their factories intelligent?
So it's a myth in a sense that you need to have very highly advanced setup to be able to actually embrace smart manufacturing. See, what needs to be understood is that smart manufacturing is not one technology which you buy off the shelf and implement. Smart manufacturing is a smart way of doing your manufacturing. And for that, automation is certainly not needed. And specifically in India, for instance, automation is one thing which could be very deleterious. Europe is going behind automation because they're having a diminishing human resource. They are not having enough people to run the factory, so they want to have automation. But in India, we don't need, which essentially means that all the traditional manufacturing industries, which are very human-centric, which do not have a lot of advanced setups, can actually embrace smart manufacturing without really requiring to go through a cycle of automation. So what I would suggest in a nutshell is that what they need to look at is that what are the key ingredients which are stopping them from advancing in terms of quality, in terms of speed of production, and in terms of losses. What are the basic ingredients? So every industry probably needs to sit back, look at their processes, look at their business objectives, and then identify what are the key ingredients which are stopping them in these three aspects. What are the key ingredients which are stopping them in creating high quality? What are the reasons why they are actually slow and agile, not agile enough? And number three, what are the main losses? And based on that, they need to create a roadmap of their own sector, of their own company, which has to be smart without really necessarily going to automation. So that is, I think, which every individual industry will have to do that on their own, to figure out what are their key business objectives, what are their infrastructural, I would say, boundary conditions, and then what should be their roadmap to achieve those. And smartness does not require automation, again, as I just rightly said. So they don't have to really invest big on automation. The same humans can work more smartly by more informed decisions because of this IoT devices. So you can essentially have the same worker of yours, but his or her productivity will go up, will be having a more safer environment, and will be having a more comfortable environment with these IoT devices and smart manufacturing devices, rather than you basically trying to replace that and provide investment in terms of automation.
Right. So let's take it as some use case. Let's with some example. Let's assume I have a small tool room with about 5 to 6 CNC machines and a design facility, and I have a CMM machine to inspection and everything, and all the other necessary technology to run a tool room. How I can, in a step-by-step manner, how I can go about it, how I can implement a smart, industrial IoT in my existing facility.
That's an excellent question, actually. So see, what happens is that let's look at a specific case, as you said, a small tool room, which has a small inventory of tools. It has specific jobs which are coming. It has a set of 4 or 5 different machines and a CMM and other things which are, so it makes a complete tool room. Now, what essentially happens is that what you will realize is the very first thing is, in a tool room, the most expensive thing is, and the most costly thing are the CNC machines, the machine tools. And thus their depreciation is the largest single cost. And thus you don't want your machines to be idle at any given point of time. So the very first thing what you want is, you want to make your machines work at the maximum efficiency. You don't want them to be not working at its maximum efficiency. Now, how would you ensure that? So essentially, if you have smart IoT devices installed on your machines, which are able to track very simply when a machine is switched on, when the machine is actually doing metal cutting, and if the machine is switched on but not doing metal cutting, then the operator can choose, for instance, from a dashboard of 5 possible options, that the time is required because of tooling. So the setup time to put the machine or the workpiece in, or it is because the tool is not available, or the human resource is not available. So some 5, 6 very simple things which the operator can do when the machine is switched on, the operator is available, but it's not cutting. Now, based on this, you could essentially look at the data. So essentially, at the end of the day, what we are trying to create is, we are trying to create data from these machines, and then perform data analytics to figure out what are the key ingredients for the losses which we have. And these losses could be of different kinds. This could be a loss because the tool was not available, so we probably didn't do a proper management of the tools. Was it because the human resource was absent, or he was on leave? We did not have a human resource. So we have to look at, are we doing a proper HR management? Is it because the gauges and other things required were not there? Or was it because the setup time takes a very long time when we change from a 5-axis to a 3-axis? And are we optimizing all our 3, 5 axes and other machines together? So this is possible to bring an efficiency of about 15%, is what, for instance, American estimates in American smart manufacturing estimates have been. In India, I feel this can even bring more than 15% efficiency. So you can essentially increase the efficiency by 15%. Now, looking at a slightly bigger picture, going a step beyond, you could actually predict, based on the devices, smart manufacturing devices on your machine, if there is a possible spindle failure which is there. You can also predict if the tool life is nearing its end and you may want to change the tool, rather than have a tool break while you are machining something. You could also look at the vibrations and temperatures at the CMM center, where you are essentially measuring, and thus you could have an understanding whether you are maintaining the environment which is required for tool measurements. So you want to be at 18 degrees C or 22 degrees C. Are you having that? Is the vibration below the specific level? All of these aspects could be all available. And this is not for a later analysis. This will be all available real time to the management to take decisions. So essentially, there are 3 ways of looking at it. One is informative analytics. So this is what all I just talked about, is informative analytics, where you are fully informed of all the situations, 360-degree situational awareness. The second aspect comes of predictive analytics, where you are able to not only know what is happening, but your smart manufacturing setups are able to predict future events, and thus you can be more informed of something which is going to happen in near future.
Yeah.
For instance, a spindle is going to break and things like that. And finally, you could also have expert systems built in your smart manufacturing, which could do prescriptive analytics, which means it could also prescribe that, you know what, this is something which is expected. Probably you may want to order a tool beforehand, or you may want to do this, or you may want to do that. So all of these three things can really be directly affecting a tool room, and a tool room can immensely benefit from it. And this really does not require automation. It just requires to empower the management and the shop floor worker with these smart devices.
That's great. Yeah, thanks for informing how to go about it and how to convert the conventional factory to a smart factory. So when I'm going and doing going about converting my factory into a smart factory, what are the things I should avoid while adopting these things?
So that's a very that's a very different question, in some sense, a loaded question. So what I should not do, the one thing which you for certainly should not do is to go into something very proprietary. Because what happens is that if you go into any of those proprietary software, you are, or in the hardware, you are pretty much tied to that smart solution provider. So you don't want to get into anything which is proprietary. You want to have systems which are open. Even if you are buying it from some proprietary, some specific company which has its own proprietary software and own proprietary protocols, you may want to say that, no, I want it to have open protocols also available. That's the very first specific aspect. The second thing is that one should not rush into getting into the tag of smart manufacturing. One really needs to sit back and create a roadmap for this. This is not something which you just do and you start getting money, every day. It's not really something which will give you dividends unless you have the context, you have the subject expertise built in it. Just AI and IoT devices will not really provide you a dividend. And that is something I think which is the most important aspect. So you need to sit back and create a roadmap and see what would be the impact of this on your bottom line or your top line for that purpose also. So these are the basic things. So just don't rush into it. Don't get into people who are providing you a very proprietary system. Finally, the last thing is that invest on human resource. More than technology, invest on good human resource, because these technologies still require human resource. So these are the basic aspects which I think they should do or not do, basically.
Yeah. So you have mentioned human resource a couple of times, and since the manufacturing and the whole world is moving toward the digitization, according to you, what skill set the upcoming or the existing engineers will have to develop in order to sustain with this new trend and be productive?
So basically, the whole idea of smart manufacturing is that you really don't need to be smart yourself. The device automatically takes care of all the aspects of smartness. Today, to use a cell phone, you don't need to know how a capacitive touch screen works. All the technology is built in it. However, at the same time, this is still at a very early stages, nascent stages, and thus you do need people who are conversant with the overall understanding of what the system is doing. You don't need to know the micro details, but you need to have people who are aware of what are the basic ingredients in terms of data which you are providing, and what are the basic outputs which the system is providing. And thus, I feel every shop floor engineer and every shop floor manager needs to have an orientation done as to realize that there is very important critical data which is being captured by these IoT devices, and these smart systems are converting that into some kind of a actionable intelligence. And that is what they need to be able to understand. So it cannot be something that, okay, I will fill the forms tomorrow. No, it is all happening real time. So that kind of situational awareness and the entire concept of real time data being production and the data being digested and the data being used to create actionable information is happening. So I think this is the basic aspect. You of course would need people who do understand the hardware and the underlying protocols, but I think that would be more of an IT kind of a person who would be required, and we will be able to have that. But that is not the main bottleneck. The bottleneck is the engineers themselves do not see the entire chain of going from data to the final, affecting their bottom line and their productivity. So that kind of orientation is required. So you really don't need to make everyone IoT smart person, but they need to be able to appreciate the entire value chain as to how it is going from sensors collecting real-time data to machine learning and artificial intelligence algorithms, changing this into actionable information.
Right. So for a successful implementation, we need computer science engineers, mechanical engineers, and maybe electronics engineers as well, and some mathematics as well, I guess.
So at the level of shop floor, you really don't need mathematics. So these are things which are being done by people who are developing AI algorithms. So you essentially need electrical, computers, and mechanical engineers primarily. Almost every engineer who has been properly oriented would essentially do, but they all need a clear understanding of what are the limitations and what are the possibilities of this. So they need to be well oriented.
Yeah, that's it. So can you share some example or a case study of a small or medium sized unit that has made a difference using smart manufacturing or industrial IoT devices? Do you have any examples to share?
So there are many examples out there. If you see smart manufacturing, and it doesn't still mean that you have automation, as I rightly said. So we did a project with a pilot project with a company an aerospace company in Bangalore. And I'm just trying to pick specific cases in which we were involved. Of course, there are a lot more literature out there. So over there, we had some very large CNC machines. So it was a machining center. It was a huge machining center. And being aerospace, it has runs of the order of 24 hours, 36 hours, sometimes over a week, the machine keeps running. And those machines cannot really have any disruption and any other such thing like that. And thus we realized that we could improve the efficiency of human resource allocation by implementing IoT device, which was continuously monitoring as to how is the pattern of usage of machine happening. And since these machines take weeks sometimes to do a single job, the optimization of which machine to use how and when was something which was possible once we were able to implement such a device. And these devices were giving live data back, and the management could basically make informed decisions based on that. So this was a huge company, this was a huge aerospace company. But looking at a small company, for instance, so there's a very different example, I would say. So we worked with a small garment manufacturer right here in the outskirts of Mumbai. And in a garment manufacturing process, it's essentially a assembly line, if you may say, something like that. So for instance, if you have to make a shirt, you have to stitch a shirt, there'll be around 25 to 35 people who will be stitching one part each. And that would lead to the final making of the shirt. So it's a beautiful system because you could very quickly adapt, learn, and then see the results of your smart manufacturing technologies. So over there, we implemented a smart manufacturing, which was just looking at how often people are working and which are the machines which are most likely to break down. It being a series process, if a single machine breaks down, you really have the entire production stopped. And the our benchmark was our neighbors in Bangladesh. The same production is being done at much cheaper cost than India. So India is really having a major, I would say, competition from them. And we realized that there are specific equipment in between in that stitching process, which were more likely to be delays. So although on a mean basis, they will be same, but they had a higher variance. And what we then came up with an idea was that you can deploy multiple people for those specific sets and have a buffer available. And we were shocked that, and these individual steps are like 15 to 45 seconds actually. But just by creating a buffer of 20 minutes, the productivity could be increased by almost 25%. And this was shocking for them as well. Now, similarly, we are actually working with a mold manufacturer in Chennai, classic dies and molds, and they are actually very forward-looking. They have been very forward-looking in terms of their adaptation of technology. They already have devices on their shop floor. We have not installed those devices. These devices have been installed by other IoT and smart manufacturing setups. And they have these devices which are continuously monitoring all their machines and giving them a single dashboard to see what machine is working when, what was the downtime, what was the ranking of the machine performance in this week, in the last week, in last month, in each quarter. And based on that, they can figure out which machine is most likely to be more productive than not, and the ones which are less productive, they can put their management and other resources to make sure it is very productive. And this is one of the classical examples where they have actually embraced the technology and are getting dividends of it. So there are many, many such examples. And all of these technologies are not very expensive because they are really small aspects which are getting integrated in your existing infrastructure. You're not really going for a major change in your infrastructure.
Yeah. That's great. That's great to know about the three different companies, how they have implemented it, got benefited. Just a couple of questions from my side more. Where do you see the industry heading in terms of adoption of the Industry 4.0 and how the scenario is different in India compared to the developed world like in Europe or USA or Japan, I would say?
So it's actually very different, especially in Europe, Germany, for instance, and in Japan. The challenges are very different from that in India. So in Germany, as well as in Japan, the human resource is really diminishing. People who will work on the shop floor are not really existing anymore. So you are not able to get workers, people retire, and then there are no new workers who are ready to join that. So over there, the flavor of smart manufacturing is more inclined towards automation. So they have more aspects of automation associated with it. However, that's true in Japan as well as in Germany. US is a little different. US actually wants to create a lot more jobs. So they are in some sense not so inclined towards automation as is the case in Germany and Japan. India, on the other hand, is the other extreme. We actually don't want automation. We want more people to be involved in the sector, or we don't want at least them to lose their jobs. So in that sense, the flavor of smart manufacturing in India is going to be of the kind that it will augment the capabilities of the human resource in performing the same task. And that is how we should move forward. Whereas that in Europe and in Japan is more to essentially automate and make autonomous robotic aspects. Whereas in India, it should be rather, I would say, it should be more driven by augmenting the capabilities of a human working in the shop floor by providing a more clearer understanding and a direction of what to do. So it's going to be basically assisting humans, whereas it may be replacing humans in Europe and Japan.
Right. Just last question. What are your suggestions to the, since most of our, joinees are from the tool making industry. So what are your suggestions to the Indian tooling suppliers regarding the implementation of Industry 4.0, or let's not use the word as you said, the industrial IoT, and what are the do's and don'ts if they are going to adopt this technology?
So I think one of the things which is very clear is that you need to embrace this technology, and it is for many other reasons apart from just the reasons of being able to produce better and cheaper and faster, but also for transparency. One other very, very key technology, which is going to come again in a very big manner, it's already there in financial sector, is the aspect of following up with the smart manufacturing is basically smart leisure technology, where you are able to have blockchains which are able to maintain information and create a link and a chain. So essentially, I would say that the Indian tooling industry should look at their business objectives. They should look at what are the deficiencies which have been affecting their basic three aspects, which is their ability to produce higher quality products, their ability to produce more and at a cheaper cost, but also the fourth aspect, which is to integrate their customers in this process in their own internal processes. And thus they should be approaching smart manufacturing with an open mind. The adaptation of smart manufacturing should be such that it should actually open a window in which their customers can see themselves getting integrated. If as an end customer, I want to know what is the status of the order which I placed, if there is one company which is able to provide me that value, that information at my fingertip versus the other is not, I would be more liable or more likely to do business with one which provides me. It's like when you get something shipped to you, the shipping company tells you that your product has reached this place, your product has reached this place, your product has reached this place. Today, the tool manufacturer should also be in a position with smart manufacturing. It would be possible to actually tell their customers that if you've ordered for something, this is where your tool is, this is where your product is, this is where your product is in its manufacturing. Moreover, the blockchain, which is probably going to be a very transformative technology for financial sector, but also for manufacturing sector, will also bring in the kind of accountability which is required, especially in medical devices, as well as aerospace components, where you need to track everything from the raw material, from the tooling to the manufacturing machine, which was used to manufacture and everything. And all of these now can be done using blockchain. So I think in future, the compliance requirements will mandate you to have blockchain, which will require smart manufacturing to be there. So these are some of the things. So future is going to be smart manufacturing. This does not mean that you have to invest a lot, but it certainly means that you have to start looking at your business processes and start seeing where you can ergonomically have these things come in.
Right. So I'll just thanks for that. That's it from my side. It was definitely insightful, and I'm sure our audience also have learned something new today and have cleared their doubts in implementation of Industry 4.0. So let's take the audience question. Yeah, so there is a question from Mr. Srinivasan. If I wanted to start with modification of one CNC machine, what are the hardware and software I have to fix in the CNC machine, and what would be the ballpark cost for the one machine? Okay.
So it is not, it's not a simple answer to say that you can just buy this, but essentially, if imagine you have a CNC machine and you want to be able to make it a smart machine. So depending upon the controller, so if you have Fanuc or Siemens or one of those leading controllers which has an open protocol available, you actually have all the data already available. What you need to realize is smart manufacturing essentially requires two things. One is data, the other is smart analytics of that data. So your IoT devices provide you the data, and most of the controllers today have this available to you. So the basic data is already available to you. It's only when you want to go beyond the basic data is that when you want to invest on some IoT device which you will install. Otherwise, your controller itself is in a sense an IoT device. So I think you need to look at what kind of controllers you have. What are their capabilities? Are they having, open protocols for communication? And there are many MT Connect and OPCA and many protocols are available. So if those are available, then you probably have to do very little investment in terms of any hardware. However, if you would like, you can install IoT devices which will measure vibrations, which can measure acoustic emissions, which can measure temperature and humidity, and they can transmit that data. But essentially, I would say that one has to look at a collective approach. Don't go for one machine and you make that install something on it. You may want to really see how is the critical, because it requires a critical mass. Unless you have that critical mass, you will not be able to see any benefits of it. So the first thing is look at if you can use your controllers without really any investment, maybe some small software here and there. If not, then you can always install IoT devices which could measure these quantities and provide you the data. So you essentially look at your business processes, start with a small shop, maybe which has 4 or 5 machines, and do it on that set rather than just one machine.
Right. So to the audience, if you have more questions, please write in the chat box and then we can take it one by one. So next question to you, Mr. Tewari, from Mr. Avinash Sinha. What about the operators working on the tool room CNC machines? Are they need to have extra skill to work on Industry 4.0, or only qualified engineers can work under this environment?
So it will defeat actually if we require very highly trained people to be working, if we want very highly trained people to be working on smart manufacturing, then it will probably defeat the purpose of smart manufacturing. The whole idea is that this technology has to make the person smart by the very fact that this technology exists. So the thing is that the shop floor worker can still work. Maybe a little training is required depending upon what kind of dashboard which you have. But essentially, I do not see any shop floor worker or CNC operator requiring a training for more than, let's say, 2 hours or 3 hours, maybe half a day training to become apt in using these devices, which will start giving the data. What you need to realize is that the interaction of the CNC operator or the shop floor operators are only going to be limited to the amount of data which they are giving. So their interaction with the smart systems will be only to provide data. The smart systems will itself do all the other analysis. So for instance, you may have a dashboard where if there's a machine downtime, if it's down, he can press the button that it's down. If he's doing a setup, he comes in the morning, the shift starts, he's setting up the workpiece, he can just press the setup workpiece and then keep doing his stuff. The moment the machine starts, the machine gets to know that from 8 o'clock till 8:45 it took to set this thing up. And then the machine is running, and suddenly if the machine is stopped, then the person can say, I'm changing the tool, or I'm not having the tool available, or something else. So you essentially get to know what is happening, and this is all what the operator may have to at the most interact. So essentially the operator needs very minimal training. You don't need very smart people. You just need to have those people slightly trained, and then the rest of the aspects are taken care by the smartness of the system.
Right. So I think there is a follow-up question from Mr. Avinash Sinha again. Can CNC machine problem be fixed from remote area?
So this is a very different thing. It depends upon what problem you have. So a CNC machine problem could be of different kinds. So depending upon what level of intervention it requires, the answer is yes. Many major manufacturers provide you a link so that they can actually take control of your CNC machine. If there are faults, there are warnings, they can actually take care of some of those warnings. But depending upon what level of problem and a fault you are facing, some can be taken care of, some cannot be. But that's not the basic aspect of the Industry 4.0 which I was talking about. What I was more talking about was kind of universal across rather than specific to a specific machine.
Right. Okay. There is another question from Mr. Naresh Verma. Industry 4.0 is a cost effective. With implementation of Industry 4.0, will product cost will increase? So he's asking, if we implement Industry 4.0 in our system, is it going to impact the cost of the product that they are selling?
That's a very good question. So what I have been telling, that look at your business processes. I think the best way to look at is look at your past. See, in last 1 year, how many disruptions you had because a system went down, a CNC machine went down. How often did that happen? Then back calculate what is the cost implication of that. When your machine was down for 4 days, what was the cost impact of that? Your human resource were sitting doing nothing. Your orders were delayed. You had to invest money. You were not getting any production. So you look at what all were the major cost drivers of your last 1 year, and then see as to what could be the impact of these smart systems in reducing those. Will they eliminate them? The answer is no. We are not aiming to eliminate them. If we can reduce it by, let's say, 70%, that's phenomenal. We can keep improving. So essentially, the cost is not to be looked at as to the amount of investment which you have done, but the totality of what it can do in terms of benefits. So I think if you just look at these three aspects, one is the equipment efficiency, OEE, basically, then the aspects of downtime and the aspects of optimal utilization of human resource. And if you could achieve that better with these systems, then you can yourself calculate what would be the cost benefit or cost benefit analysis of this. And I'm sure that everyone will be able to realize that this will be not a cost center. Actually, it will be a profit center in some sense. It will help you reduce your cost.
Yeah. Right. So there is an interesting question from Mr. Siddharth Guha. What is the use of AR and VR in tool room environment?
What is the ARN?
VR. I
Acha,
think he's
virtual
talking
reality.
about
Okay.
augmented reality and virtual
Augment and
reality.
virtual reality, yes. So
Yeah.
basically, there are many aspects of it. You could be, for instance, in the area of CMMs when you are essentially measuring things. Virtual reality would certainly help you. Augmented reality will help you. Your operator does not need to be fatigued and look at all the aspects of augmented reality, is able to provide all of that information. Yeah. But I personally believe that augmented reality and virtual reality are a larger investment with a slightly lesser dividend in some sense. So that should not be the first step which one should look at going for smart manufacturing, because virtual reality and augmented reality sometimes could be very expensive to implement, and they only reap benefits when you are at a very high end cost. But essentially there are ample of cases where augmented reality and virtual reality will help you. For instance, cannot inspect something without really going at the back and looking at it, whereas augmented reality could provide you a very quick understanding. You may have a camera over there, it can provide you if it's good to go or not. So augmented reality certainly has a room, specifically I feel in the quality assurance and testing and measurement and CMM, and to some extent in machining also. But it may not be the first thing which you may want to start implementing when you look at smart manufacturing.
Right, right. So there is another question from Mr. Arvind Chawla. As you know, tool room jobs are tailor-made and not like production job wherein the repeat jobs are made. How you compare the implementation for this difference in implementation?
That's actually very true. So that's where I think the maximum benefits can be reaped. Just imagine if you have a machining center where you are having 100 jobs of the same kind. If you're having 100 jobs of the same kind, you probably have already optimized the process and you will be having a most optimal process one after the other to run those 100 jobs. The main advantage of smart manufacturing comes when you have a variety of jobs. No two jobs are similar. That's when these systems will be able to provide you an optimal solution. It will be able to tell you what is the best mix of operator, machine, and the job sequencing to obtain what you're trying to obtain. So that is actually the basic advantage. If you have 100 jobs of the same kind, or for the entire week you'll be making the same exact gear again and again, there is very little which a smart manufacturing will help you with. It can still help you with if there is a maintenance problem. It can predict if there is a failure or such things. But when it comes to scheduling and aspects associated with optimal choices of resources, that's when this will really be the most optimal thing to go forward.
Right, right, right. From Mr. Gopala Krishnan, is it possible to have a common platform or a package to accommodate the basic shift to smart manufacturing for a general tool room of a medium size?
So this is something which is $1 million question. So every company and large corporates to smaller companies are all trying to have their own, I would say, offerings. And all of these offerings are unfortunately not really gelling with each other. They don't talk very well to each other. And though there are some standards which are already out there, however, there is no consensus on these standards. So the answer in a nutshell is no, there is no such offering. You have to really look at and work with the service providers and see as to what would be the subset of the technologies which they have, which will be of helpful to you, because they may just push all what they have and that all may not be needed by you. So it has to be done on a case-to-case basis, and this is where we are still evolving. I'm hoping in next 5 years world will be evolved enough that we would not be having this kind of an issue.
Right, right. So since we are running out of time, we'll just take a couple of more questions. From Mr. Vijay Kumar, any total smart system is available to improve the quality and lead time for tool room? If available, where? So I think these are the product-based questions. So
this is very specific aspects. There is no such. So there are hundreds of companies in India and abroad which are trying to sell you something or the other which will do that. The question is as to what is that you want and what offerings they have. So it's more specific. You'll have to look at on a case-to-case basis.
Right. I think there are a couple of more questions. I think in the same line. Can you suggest any software or application where I can get all tool maintenance data like tool history, product management planning, breakdown reports, etc.? Yeah.
So then there are several ERP systems which are available, and those ERP systems. So essentially, if you look at smart manufacturing, it has come from two sides. There are ERP companies, and I don't want to take their names, but you know them, big ERP companies, which have actually moved to smart manufacturing by providing you a real-time understanding of your inventory and history. On the other hand, there are big manufacturing companies which makes controllers and others. They have moved towards ERP in providing this data. Now, there are many other open source ERP codes also available. Unfortunately, they are not so simple for you to use without really having an expert at your end. If you visit these exhibitions, you'll find there are many small companies which are providing these solutions. But I would say that one has to look at a subset. Don't get into a very big automation of all aspects unless you are ready for that. You may want to firstly create a roadmap and go stage wise, phase 1, phase 2, phase 3, and deployment on that basis.
Right. So I think it looks like we are running out of time, so we'll have to close the session. But before we close this, I think Mr. Shan Sundaram would like to say a few words. Mr. Shan?
Good evening, Doctor. Thank you so much for being with us and sharing your valuable inputs about Industry 4.0. I thank all the participants. I am sure today's interaction is useful to all of us. Furthermore, I request all the participants and members to drop a mail if any specific areas of interest so that TAGMA can arrange the future talks accordingly. Thank you so much to one and all.
Thank you.
Thank you so much, Mr. Tewari. It was nice having you here today, and definitely we have learned a lot today. But if anyone has still some questions, please write to TAGMA, and we'll get back to you with Professor Tewari's response. Thank you all for joining today. I hope you all enjoyed the session. Thank you so much, Professor Tewari, again.
Thank you. Bye now.